So we've covered all the key skills that you'll need for doing any integration question when it comes to higher level mathematics. What we're going to do in this video, I'm going to present you 3 past paper questions, 2 non-calculator, 1 calculator, all relating to the skills you should now be able to use involving integration. I want you to pause the video, have a crack at them, and then come back and see the work set of solutions I'll present here for you. Here they are. So the first one is evaluate this definite integral between -4 and 9 of this function here. The second one is for a function f defined on a suitable domain, it's known the derivative equals this, and f of 9 equals 40, express f of x in terms of x. And the last one is, here's a diagram with a function y equals 3 plus 2x minus x squared, calculate the shaded area. So pause the video and have a crack. So the first one, evaluate the integral from -4 to 9 of 1 over cube root of 2x plus 9 squared dx. Well, the first thing we have to do is write it in a form we can integrate. So we take it, an integral from -4 to 9, change this into a power, 1 over 2x plus 9 to the 2/3 dx. We then have to bring it up, so make the power negative, and we get the integral from -4 to 9 of 2x plus 9 to the power -2/3 dx. Now, remember, when we integrate this, we raise the power by 1, divide by the new power, and then divide by the derivative of what's in the bracket, which in this case will just be the coefficient of x. So what I then get when I integrate it is I get 2x plus 9, -2/3 plus 1 gives me 1/3, and then it's divided by 1/3, and also divided by the 2, so multiply the bottom there by 2. And that's between -4 and 9. We now have to simplify this, so 1/3 times 2 gives me 2/3, and I'm dividing by 2/3, so that then becomes 3 over 2. And then 2x plus 9 to the 1/3, well 1/3 is cube root, so it's then the cube root of 2x plus 9. And that's all between -4 and 9. So I've now got my form. It's in a form where I can work with it with these values. I now have to evaluate it. So I've got 3 over 2 times the cube root at the upper limit of 2 times 9 plus 9. Take away 3 over 2 times the cube root of 2 times -4 plus 9. So I've got to evaluate both these and then calculate the difference between them. So 2 times 9 is 18, plus 9 is 27, cube root of 27, that's 3. So I've then got 3 over 2 times 3, that gives me 9 over 2. Let's then take away, well 2 times -4 is -8, plus 9 is 1, cube root of 1 is just 1, so it's then 3 over 2 times 1, which is then take away 3 over 2. 9 over 2 take away 3 over 2, that gives me 6 over 2, which is then 3 units. So 3 of whatever unit it's after. So there you go, that's the integral there for that one. Remember these key steps. First put it in a form you can integrate, which gets us to here. Then integrate it, remembering these facts here, and sort it for when you put the values in. Then you put the values in and find the difference. Next one, so function f is defined in a suitable domain. It is known that f dash of x equals 2x plus 1 over root x. F of 9 equals 40, and f of x needs to be expressed in terms of x. So first thing we need to do, write f dash of x in a form we can integrate. Integrate it and we'll get a plus c, a constant, and then use this to eliminate the constant. So we have to write f dash of x, split it into 2 fractions. So we get 2x over root x plus 1 over root x. What we can then do is split these up, simplify them, and we've got our answer. So 2x divided by root x, well x divided by root x is just 2 times root x. It's plus, well 1 over root x becomes 1 over x to the half, which becomes plus x to the -1/2. Write the root x as x to the half, and we're ready to rock and roll. Integrate it, and then we start. So we then know f of x is the integral of this, so I've got 2 times x to the 3 over 2 divided by the new power, so divided by 3 over 2, plus x to the 1/2 divided by the new power of 1/2 plus our constant of integration. So we can then simplify these bits. So this one here, 2 times x to the 3/2 divided by 3/2. Well, remember, dividing by this, you flip it and make it a times. So that gives me 4/3 times x to the 3/2. Well, x to the 3/2 we have to write in a slightly different form in order to be able to use it. Anything to the 3/2, remember the 1/2 gives me a square root, and the 3 gives me cubed. So that gives me the square root of x to the power of 3, plus, again, dividing by a fraction, flip it. That becomes 2 x to the 1/2 square root of x, plus my constant of integration, c. So that's us got the general equation there, but now we have to use this. Now we have to use the f of 9 equals 40 in order to be able to get our constant of integration. So, let's crack that. F of 9 equals 40. What that means is 40 equals, and substitute in 9 wherever there's an x. 4/3 bracket square root of 9 to the power of 3 plus 2 times square root of 9 plus c. Now we have to solve this. We'll get our c, we get our equation. So 40 equals, well, square root of 9 is 3. 3 cubed is 27. So it's 4/3 times 27 plus 2 times the square root of 9. Well, square root of 9 is 3. 2 3s are 6 plus c. 4/3 of 27. Well, 27 divided by 3 is 9. 9 times 3 is 36. 36 plus 6, 42. So I get 40 equals 42 plus c. From that, I know c equals -2. I've got my constant of integration. Now all I have to do is plug it in. Don't ever leave it at this stage. You have to physically write out f of x equals and get your equation. So I know in this case, f of x equals 4/3 root x to the power of 3 plus 2 root x minus 2. There you go. We've got our function there. We've got f of x in terms of x. We never ever leave the c in when we have a condition like this. Last one was calculating the shaded area here. Now remember, calculating the shaded area is the integral from one limit to the other of our function. So the area here, a, is given by the integral from -1 to 3 of our function 3 plus 2x minus x squared dx, so all with respect to x. So we integrate this, substitute the top limit, substitute the bottom, find the difference, and we're there. So integrating that gives me 3x plus 2x squared over 2, take away x cubed over 3 from -1 to 3. Substitute these in, let's see what we get. So it's 3 times 3 plus 2 times 3 squared over 2, take away 3 cubed over 3, that's the upper limit. Then we do it for the lower limit at -1, 3 times -1 plus 2 times -1 squared over 2, take away -1 cubed over 3. Do each term, simplify the brackets, and then find the difference. So 3 3s, that's 9. 2 times 3 squared divided by 2, well again that's another 9, so that's plus another 9. 3 cubed over 3, well 3 cubes 27, divided by 3, that's then minus 9. Then I've got to take away the second bracket, so 3 times -1, -3. 2 times -1 squared divided by 2 gives me plus 1, and then -1 cubed over 3 minus -1 over 3 gives me plus 1/3. 9 plus 9 minus 9, well that's simply 9. Take away, so -3 plus 1 is -2, plus another third is -1 2/3, which I can simplify and keep as an improper fraction as -5 over 3. Remember, minus minus here becomes a plus, so it's 9 plus 5 over 3. Well, 9 we can write as 27 over 3. 27 plus 5 all over 3 gives me 32 over 3, or 10 2/3 units squared. So there we go, we've got our final answer. Unless it asks for a specific form, improper fraction or mixed number are both perfectly acceptable. These are classic examples of exam questions. These are the kind of things that come up for integration. Finding the area under curves, finding the area between two curves, calculating a function given some initial condition in the derived version, or just being able to do an integral between two limits. These are the kind of things you now have to be able to do when you're working with integration.